Preparing for an infrastructure engineer interview questions and answers interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does an infrastructure engineer do, and how do you measure success in the role? I see infrastructure engineering as building and operating the systems that let application teams deliver safely and reliably. That includes compute, networking, storage, identity, observability, deployment platforms, and automation. I measure success through availability, latency, recovery time, deployment frequency, change failure rate, infrastructure cost, and developer experience. A strong infrastructure team does not simply keep servers running. It creates reusable, secure paths that reduce operational toil while preserving appropriate control for specialized workloads. While answering, define infrastructure engineering broadly, discuss platforms and automation, and connect responsibilities to reliability, scalability, security, developer productivity, cost efficiency, service level objectives, and measurable business outcomes. Question 2. How would you design a highly available service across multiple availability zones? I would distribute stateless service instances across at least 3 availability zones behind a health-aware load balancer. Data would use a managed, multi-zone replication strategy, with clearly defined consistency and failover behavior. I would remove single-zone dependencies such as local-only queues or unreplicated secrets, then automate provisioning through infrastructure as code. Finally, I would test instance, zone, dependency, and network failures using controlled drills. High availability is demonstrated by recovery behavior, not merely by having redundant resources. Make sure to cover redundancy, stateless application instances, load balancing, health checks, replicated data, quorum or failover behavior, zone isolation, infrastructure as code, graceful degradation, and testing failure scenarios regularly. Question 3. What is infrastructure as code, and how would you use it safely in production? Infrastructure as code represents desired resources in versioned, reviewable configuration rather than manual console actions. I would use reusable modules, remote state with locking, isolated environments, and pull request plans that expose changes before approval. Secrets should come from a dedicated secret manager, never committed files. Policy checks can block public storage or oversized instances automatically. I also schedule drift detection and maintain recovery procedures for state corruption. The goal is reproducible infrastructure with controlled, auditable change. In your answer, talk about declarative configuration, version control, review workflows, state management, modules, secrets handling, plan and apply stages, drift detection, policy checks, rollback strategy, and environment promotion. Question 4. How would you troubleshoot a sudden increase in application latency? I first confirm the symptom by checking latency percentiles, affected endpoints, regions, and customer impact. Then I correlate traces, logs, resource saturation, database performance, network metrics, and recent deployments. I separate application latency from downstream dependency time before choosing mitigation, such as rollback, traffic shifting, capacity increase, or feature disablement. I communicate findings and status while investigating. After recovery, I document the timeline, identify the contributing change, and add detection or safeguards so the issue is less likely to recur. Be sure to mention symptom validation, scope and timeline, dashboards, traces, logs, saturation signals, recent changes, dependency analysis, rollback decisions, mitigation, communication, and post-incident prevention. Question 5. Explain the difference between containers and virtual machines. When would you choose each? A virtual machine emulates a complete computer through a hypervisor, including its own operating system kernel. A container isolates processes while sharing the host kernel, so it starts faster and usually provides better density. I choose containers for portable services, batch jobs, and consistent deployment pipelines. I choose virtual machines when stronger isolation, custom kernels, legacy operating systems, or incompatible drivers are required. Containers are not automatically safer. Kernel vulnerabilities and weak runtime configuration still matter. Focus on kernel sharing versus hardware virtualization, startup time, isolation strength, density, portability, operational overhead, security boundaries, workload compatibility, and situations where containers or virtual machines are more appropriate. Question 6. How would you build a reliable CI/CD pipeline for infrastructure changes? My pipeline would format and validate configuration, run module tests, scan dependencies and policies, generate a reviewed plan, and apply only after required approvals. Changes would promote through isolated environments, beginning with a small or low-risk target before broader rollout. I would lock shared state, record artifacts and identities, monitor the deployment, and stop automatically on defined health failures. Rollback may mean reverting configuration or restoring a known good state, so I design both paths before deployment. Discuss validation, formatting, unit and integration tests, security scanning, plan review, approval controls, staged rollout, environment promotion, state locking, monitoring, rollback, and separation between code authorship and production access. Question 7. What is the difference between horizontal and vertical scaling, and how do you choose? Vertical scaling increases CPU, memory, or storage on an existing machine, while horizontal scaling adds more machines or service instances. I use vertical scaling when simplicity matters, the workload is difficult to partition, or a database needs a larger node. I use horizontal scaling for stateless services and elastic demand, accepting load balancing and coordination complexity. In practice, I often combine both, right-size individual nodes, then scale the fleet while monitoring bottlenecks and failure domains. Make sure to explain adding resources versus adding instances, capacity limits, cost, state management, coordination overhead, workload characteristics, elasticity, and why a hybrid scaling strategy is often practical. Question 8. How would you secure a cloud environment for multiple engineering teams? I would separate environments and high-risk workloads using accounts, projects, or subscriptions, then centralize identity through federation and short-lived roles. Permissions would follow least privilege, with production access requiring stronger authentication, approvals, and auditing. Network boundaries, private endpoints, encryption, managed secrets, vulnerability scanning, and centralized logs provide layered protection. Policy as code can prevent unsafe resources at creation time. I treat security as continuous control validation, not a one-time architecture review. In your answer, cover account or subscription boundaries, least privilege, federated identity, role separation, network segmentation, encryption, logging, policy enforcement, secrets management, vulnerability management, and continuous compliance. Question 9. What is observability, and which signals would you instrument for infrastructure? Monitoring tells me whether known conditions are healthy. Observability helps me understand unknown failure modes from emitted evidence. I instrument latency, traffic, errors, and saturation, alongside infrastructure metrics such as CPU, memory, disk, network, queue depth, and capacity. Structured logs and distributed traces should share request identifiers for correlation. Alerts need owners, thresholds, and runbooks, not merely noise. I also control metric cardinality and retention so observability remains useful and affordable at scale. Be sure to distinguish monitoring from observability, explain metrics, logs, traces, and events, and include golden signals, saturation, correlation identifiers, actionable alerts, dashboards, retention, and cardinality management. Question 10. How would you respond to a production incident involving a failing database? I would establish incident ownership, quantify customer impact, and stop avoidable changes while checking database health, replication, connections, storage, locks, and recent deployments. Depending on evidence, I might reduce traffic, enable read-only mode, fail over, or restore from a verified backup. I would communicate regularly with stakeholders and preserve logs before disruptive actions. Recovery is not complete until application behavior and data integrity are validated. Afterwards, I would conduct a blameless review with concrete corrective actions. Discuss incident command, impact assessment, read-only or failover options, backups, replication health, connection control, communication, evidence preservation, recovery validation, and a blameless post-incident review. Question 11. How do you manage secrets, credentials, and certificate rotation? I store secrets in a managed secret system, encrypt them in transit and at rest, and grant access through workload identity rather than embedded keys. Wherever possible, I use short-lived credentials and automatic rotation. Applications should reload updated values safely, while certificate renewal needs monitoring well before expiration. I prevent leakage through repository scanning, log redaction, and restricted debugging output. Rotation must include revocation and rollback procedures because an untested rotation can become an outage. Focus on secret managers, short-lived credentials, least privilege, encryption, workload identity, automated rotation, versioning, revocation, certificate renewal, audit trails, and preventing exposure through logs or repositories. Question 12. What is a disaster recovery strategy, and how would you define RTO and RPO? RTO is the maximum acceptable time to restore service. RPO is the maximum acceptable data loss measured in time. I define both through business impact analysis, not technical preference. Then I choose backups, replication, warm or active regions, and recovery procedures appropriate to each tier. I document dependencies, credentials, DNS, and capacity because restoring one database is insufficient if the application cannot start. Regular restore exercises validate integrity and reveal assumptions that architecture diagrams hide. Explain recovery time objective and recovery point objective, business impact analysis, backup versus replication, recovery tiers, regional failure, dependencies, restore testing, data integrity, and trade-offs between cost and resilience. Question 13. How would you reduce infrastructure costs without harming reliability? I begin with cost attribution by team, service, environment, and resource type, then identify idle capacity, oversized instances, unused storage, and inefficient data transfer. Right-sizing, auto-scaling, lifecycle policies, and scheduled non-production shutdowns usually provide safe savings. I may use committed capacity or interruptible instances where workloads tolerate disruption. Every optimization needs reliability guardrails, such as minimum capacity and recovery requirements. I track unit economics, because lowering the bill while increasing incidents or engineering toil is not real efficiency. Mention usage measurement, right-sizing, auto-scaling, commitment discounts, scheduling, storage lifecycle policies, spot capacity, shared platforms, cost allocation, performance guardrails, and avoiding savings that weaken availability or recovery. Question 14. How do you design capacity planning for a rapidly growing service? I model demand using traffic, payload size, concurrency, seasonal patterns, and business forecasts, then translate those inputs into resource requirements through load tests. I identify the first bottleneck rather than relying on aggregate CPU alone, and maintain headroom for spikes and failed capacity. Quotas, provisioning lead times, regional limits, and dependency capacity belong in the plan. I review forecasts against actual utilization regularly and test degraded scenarios, because capacity must support both growth and failures. In your answer, cover demand forecasting, workload modeling, headroom, bottleneck identification, scaling limits, load testing, quota management, lead times, cost implications, and capacity plans for normal and failure conditions. Question 15. How would you choose between a managed service and operating infrastructure yourself? I compare managed and self-operated options using total cost, reliability, security, performance, compliance, portability, and required expertise. A managed database may reduce patching, backups, and failover work, allowing engineers to focus on product value. Self-hosting can make sense for unusual performance requirements, strict control, unsupported features, or significant scale economics. I also examine provider limits and exit plans. The right choice minimizes undifferentiated toil while preserving capabilities the business genuinely needs. Discuss total cost of ownership, operational burden, control, performance, compliance, customization, service maturity, failure modes, portability, staffing, and whether the team gains meaningful strategic value from self-management. Question 16. What are the key considerations when designing a Kubernetes platform? I design Kubernetes around workload isolation, clear cluster ownership, and a supported developer path rather than exposing every platform detail. Resource requests and limits enable scheduling, while namespaces, policies, service accounts, and network controls establish boundaries. I provide reliable ingress, storage classes, autoscaling, logging, metrics, and secure image delivery. Cluster upgrades, backups, and node failure recovery need automation and testing. Kubernetes is valuable when its operational complexity is justified. Otherwise, a simpler managed platform may be better. Be sure to mention workload isolation, cluster boundaries, scheduling, resource requests and limits, networking, ingress, storage, upgrades, security, observability, autoscaling, backups, and developer experience. Question 17. How would you investigate intermittent network connectivity failures? I would map the failing request path and compare successful versus failed requests across clients, zones, and times. I would check DNS resolution, routes, security rules, load balancer health, connection limits, packet loss, latency, and interface saturation. Flow logs and traces help localize the failure. Targeted packet captures can confirm handshake or retransmission problems. I correlate symptoms with deployments or network changes, reproduce under controlled load, and apply the narrowest mitigation before changing multiple components at once. Focus on defining affected paths, packet loss and latency, DNS, routing, security groups, load balancers, saturation, time correlation, distributed tracing, packet captures, recent changes, and controlled reproduction. Question 18. What is configuration drift, and how do you prevent it? Configuration drift occurs when deployed infrastructure no longer matches its declared source of truth. It commonly comes from manual console edits, emergency fixes, or unmanaged dependencies. I prevent it through infrastructure as code, restricted production access, automated plans, drift detection, and reconciliation. For emergencies, I use audited break glass procedures and immediately encode the valid change afterward. Immutable replacement is often safer than repairing long-lived servers. The important principle is making actual state explainable and reproducible. Explain divergence between declared and actual state, causes such as manual changes and emergency fixes, detection, reconciliation, ownership, immutable patterns, approved break glass access, and documenting temporary exceptions. Question 19. How would you migrate a production workload to a new region or cloud provider? I start by documenting dependencies, data flows, compliance requirements, performance targets, and rollback constraints. I build the destination through repeatable automation, then validate application compatibility, identity, networking, observability, backups, and operational access. Data migration may use replication followed by a controlled synchronization window. I would run both environments in parallel, shift a small traffic percentage, compare health and business metrics, and expand gradually. DNS or routing rollback remains ready until stability and data correctness are proven. Discuss requirements, dependency mapping, data migration, compatibility testing, network and identity design, parallel environments, traffic cutover, rollback, observability, stakeholder communication, and validating performance and compliance. Question 20. Tell me about a time you automated a repetitive infrastructure task. How did you evaluate the result? I automated recurring environment provisioning with a versioned module and a pipeline that validated inputs, applied policy checks, and produced consistent outputs. Previously, engineers followed a manual checklist, which created delays and configuration inconsistencies. I tested the module in isolated environments, documented the interface, and rolled it out with a migration path for existing users. I measured provisioning time, failure rates, support requests, and adoption. The biggest lesson was to design automation around user workflows, not just technical elegance. In your answer, describe the original toil, risk and frequency, design choices, testing, rollout, adoption, measurable time savings, reliability improvement, maintenance cost, and lessons learned from users. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.